Hi guys, I wanted to touch base with you and make sure that you understand how you can use graphs to determine if something is undergoing constant speed or constant acceleration. So we have two different graphs that we look at. We look at position graphs and we look at velocity graphs. On a position graph, if the position graph is flat, it's at rest. If the position graph has a constant slope, is a line, then its distance is going up the same amount every instant in time, and that is constant speed. So if you have to decide whether something is traveling at a constant speed with a position graph or distance graph, you want to look for a line. And the slope of that line, if it's constant, means that it has a constant speed or velocity. If the slope is changing and parabolic, then it has a constant acceleration. So constant speed on a position graph is a line with a constant slope. Constant acceleration on a position graph is a parabola or a quadratic equation. Velocity is a little different. If you're traveling at a constant velocity, then the velocity graph will stay at the same velocity every instant in time. It'll be flat. But if you're increasing or decreasing your speed at the same rate every instant in time, then it'll be a straight line with a constant slope, and that slope will be your acceleration. So in the activities that you did in Pivot this week, you had to determine that in a couple different ways. So the first thing you had to do was you had to look at this little toy car, and you had to decide if the spring in it was exerting a constant force. If a constant force is being exerted, then it will exhibit a constant acceleration. So you could do that two different ways. You could plot the position versus time, and if it was a parabola, to verify it's a parabola, do a curve fit and insert a quadratic. And if you look at this, I did that, and I had a coefficient of centimeters per second squared, which tells me that it is accelerating. And it turns out that coefficient is half of its acceleration. So if that's 80, then it had an acceleration of 160 centimeters per second every second. So that means it's got a constant acceleration, thus a constant force pushing on it. Now, some of you guys said, well, my points didn't fit on the line. But remember, video analysis is really subject to you and how you collect your data. If you're not really careful, don't use the same point every instant in time, and you don't record the values right, then you're going to have problems. You can also look at the velocity graph. If the velocity graph was a line, now it looks like it's a parabola here, but let's see what the line looks like. Now notice this little thing called RMSE. If that is 0, then it's a good fit. That is not 0, it's 0.8, so it's not a good fit. I'm going to go and do a line on this. And it's a better fit. So what I'm finding is that if I do a line here, and the line is constant, and it is, then I have a constant slope of 160 centimeters per second every second. So yes, it's a constant slope, and because it's a constant slope, there's a constant force acting on it. Constant slope on velocity graph means constant acceleration. Now, in your projectile lab, you were looking at two different things. You were looking at the horizontal motion and the upward and downward motion, the vertical motion. So when you made your graph, you should have had a position in the x direction column, a y position column, and a velocity in the y direction column. That's what I was looking for. Now, remember, the first thing you had to do is you had to look at the x position. Notice that that looks like a line, so I'm going to fit a line to it. And it has a very small RMSE, 0.0, that's good. So that means it's a good fit. And it has a constant slope. So remember, slope on a position graph is velocity. So if it has a constant slope, it has a constant velocity of 6.43 meters per second. And that's what projectiles should have. A constant velocity. Should not be accelerating in the x direction. Now, the next thing you had to do is you had to look at the y position. Remember, on a position graph, if it's accelerating, it will have a parabolic shape. When I look at those data points, they do not go through that line at all. They look like a parabola to me. Now, I'm going to do a curve fit. I'm going to do a quadratic. And that's a super good fit. It's 0.01 RMSE, so it's a really good fit. All the points are there. So if I look at that, this tells me that the slope of it is changing by the same amount every instant in time. So when you look at this and you do the curve fit, you see that it is a parabola and that the coefficient A is about half of what gravity should be, so that looks good. So this definitely shows that it is accelerating at a constant rate in the y direction. Just to verify that, we're going to look at the Vy graph. You remember, in velocity, acceleration is a straight line. So when I look at that, I see a straight line. And if I do a curve fit on that, do a linear fit, gravity should be the slope. And it is pretty close to it. It's negative 9.74 centimeters per second every second. So the shape of the velocity graph in the y direction is a line. That means that the slope of it is acceleration. It is a constant slope. It is a constant almost negative 9.8 meters per second every second. So that's pretty good indication that this object is doing exactly what it's supposed to do. It's traveling forward at a constant speed and it's traveling up and down, accelerating at negative 9.8 meters per second every second.